Bright Tuty. Every student matters.
Hello dear students, welcome to another lecture. In this class, we are going to continue with Unit 14 of Class 12 Education Nagaland Board, which is Measures of Central Tendency. In the previous video, we've talked about the meaning of the term measures of central tendency and what are the characteristics of a good measure of central tendency. There are three important measures of central tendency, namely mean, median, mode. In this lecture, we are going to discuss at length about what is mean and how to calculate mean in the individual series. Okay? So basically, mean is that device which helps us to reduce a very large number of data or a large observation which is given to us in a single figure. As I gave you an example, if there is a group of information which is given to you and you have to find one number that represents that entire group, how do we calculate that? By calculating the mean or the arithmetic mean. How do we define arithmetic mean? It is the sum of the values of the observations divided by the number of observations. And how do we denote mean? By using the alphabet M, the capital M. Okay? According to Ferguson, mean is the sum of the measurements divided by the number of measurements in that set. Now, what is the objective? Why do we have to calculate the mean? What is the function of calculating a mean? First, it is going to help us understand the complex data which is given to us. Studying and analyzing the entire data is a very cumbersome, is a very difficult process, and therefore we have to make sure that after deriving one number, we can study the entire data set. So, average or an arithmetic mean is going to summarize my complex data in a very simple and concise manner, so that looking at that data, I can get to know the information about the entire data that was given to me. First. Second, as we have discussed, it helps us to compare the two set of information given to us. As I gave you the example of the teacher who wanted to assess a group of students. So earlier when the mean was, the average was 3 out of 20, the teacher knew that kids have not understood the topic. So she revised the topic again and came to 15 or 18 average out of 20. So she was able to compare now that over this month and after revising the topic, the students have been able to get through the data carefully and they are clear with the information. So it helps one to compare the data. It helps you to learn about the world from a sample, as I again said. From the group of 100 students, it is going to let you know about the entire 100 students from just one number that you have calculated. You know, in general life also, we have something known as the sample survey. You are going to learn it if by chance any of you pursue economics when you go, when you go to your college for your higher education. So, calculating or studying the entire population is at times not feasible when the duration is less. So what do? We pick up a sample and we analyze that sample, and on the basis of that sample, we derive the conclusion on the basis for the entire group. So this sample represents the entire world, and this is exactly what an arithmetic mean does. One number represents the entire set of information, the entire set of data which is given to us. Now, what are the characteristics? What are, the features of a good average, a good mean? It should be rigidly defined. It means that the number that I derive out of my calculation should be fixed. It should be stable with no variation in it. It should include all the numbers of the observation. It should be based on all the observations of the series. It should be easily comprehended. It should be, easy for one to understand the data. The average that you calculate should be easy. Again, the method that you are using to calculate the average should be easy and it should be quick enough for you to do so. Also, the effects of fluctuations of the sample, they should, affect the average as little as possible. Let's say if from a group of 100, I include 3 or 4 more students in the class, my average would certainly fluctuate because now their marks have been added, the number of observations have increased. But the fluctuation, the change should not be a very big or a drastic one. It should be a very minimal change. Last but not the least, average should be able to be located so that looking at the graph, you can get to know what is the average of the group that you are trying to study. Now, how do we calculate? As I have told you in this chapter, in this unit, you need to expect the numericals more than the theory. Now, the data can be classified in 2 broad categories. It can be either ungrouped data or it can be grouped data. Okay? We are going to learn about the calculation of arithmetic mean in all the 2 broad categories of data. First, if we talk about the ungrouped data. Now, there are 3 methods of calculating arithmetic mean in ungrouped data. The first one is known as the direct method. Okay, I am going to explain you the method here and then we'll move on to the other page. Now, how do we calculate the mean of an arithmetic of an ungrouped data using direct mean? What is the step? First, I am going to calculate the sum of all the observations given to me. Okay. How do I notify my observations? Using the alphabet X. And the sum, we know this is how we represent the summation of something. So the sum of X. And then I am going to divide it. Divide the sum of X by the number of observations. Which is represented by the number n. So what is the formula for calculating mean of an ungrouped series using the direct method? Mean is equals to sum of X divided by n. This is how you are going to get the mean of a series which is ungrouped in nature. For example, let us look at an example now. You can see the numbers in front of you. These are observations. I'm going to add all the observations as we've discussed and divide them with the number of observations, which is 5. So the sum that we get is 281 divided by 5, which is 56.2. So the average score in psychology of these 5 students was 56.2. So this is the first method of calculating mean of an ungrouped series. If we consider another example, there are 6 families and their monthly savings are given to you. I have to calculate the average monthly savings of these 6 families. What will I do? I am going to add all these numbers and divide them by the number of families, that is 6. So, on doing it, I get is 15,467, which is the average monthly salary of the 6 families. So this was how we calculate the mean using the direct method. Now, how do we calculate the mean using the assumed mean method? Assumed mean is the second method of calculating mean. Now, at times, the number of observations in the series are a lot. And because of that, it is very difficult to calculate the mean using the direct method that we have just learned about. So, how can we calculate the mean? We first have to assume one number from the data which is given to you. So one number that you are going to assume, and that is going to be called as the assumed mean. Okay, you are given with x. We know what is x. We are going to classify the data which is given to us under the category of x. So out of my x, I will take one number to be my a, which is my assumed mean. Next, I have to calculate the deviations. Deviations is represented by d. What am I supposed to calculate? The deviations. That means from each number of x, I am going to subtract my assumed mean, which will give me my deviation. Now I am going to calculate the sum of my deviation. I have calculated the deviation. Now I will calculate the sum of the deviation. And how do I calculate the final mean? What is the formula for that? As you can see, this is the formula for calculating the mean by the assumed mean method. So what did I do basically in the assumed mean method? You have a group of data, let's say x, I have 10, 20, 30, 40, 50. This is the data which is given to me. I have to calculate by the assumed mean. So one number out of this x, I'll have to take as a. Let me take 30 as the assumed mean. So my assumed mean is 30. It can be any number. You can take 10, 20, 30, 40, 50. We prefer to take the middle value, but it can be any number. After x, what do we need? We need the d, the deviation. And how do we calculate the deviation? By subtracting the assumed mean from x. Now start subtracting. X, that is 10 minus 30 is minus 20. 20 minus 30 is minus 10. 30 minus 30 is 0. 40 minus 30 is 10 and 50 minus 30 is 20. Now what do you have to do? You have to calculate the sum of assumed mean. What was the formula of assumed mean? Assumed mean plus the sum of deviation upon n, right? My assumed mean is 30. What do I need next? This sum. Now calculating the sum, the reason why we always prefer to take a middle value as the assumed mean, dear students, is because like this the calculation becomes easy. You see, minus 20 plus 20 gets cancelled out. Minus 10 plus 10 gets cancelled out. What is my sum of d? It is 0. So 0 upon n. How many values do I have? 5. This becomes 0. So what is my mean in this category? It is 30. So you see, it is very simple to calculate the assumed mean. So next, what is the formula for calculating assumed mean? A plus summation d upon n. This is how I calculate assumed mean in the ungrouped series. Next, we have step deviation method. How do we calculate it using the step deviation method now? Now this is an example which is given of assumed mean. We've already learned how to calculate, so I'm sure you'd be able to do that. So let us move on to the step deviation method. In this, if you can see, more or less the formula is same. There are just two new things which have been added. One is this d dash and the other is d. We know what is d. D was x minus a, right, where a was the assumed mean, and subtracting my assumed mean from every number of x, we get d. Now what is d dash? X minus a divided by c. And what is c? C is the common factor. Looking at the data, the observations that are given to you, you will always get a common factor. You know, for example, when we saw this data which was given to us, what was the common factor in them? 10, 20, 30, 40, 50. The number 10 was common because there was a difference of 10 in all of them. So, similarly, you will have to find a common factor, you know, in case of the series which is given to you. After calculating the common factor, you are going to divide c by that common factor and get d dash. For example, if we continue the same question that we did above, where x was 10, 20, 30, 40 and 50. I took 30 to be my assumed mean. I calculated d, which is x minus a. I got minus 20, minus 10, 0, 10, 20. Now for step deviation, I have to calculate d dash. And what is d dash? X minus a divided by the common factor. Now what is the common factor that we can see? It is 10. So, minus 2, if I divide 20 by 10, minus 2, minus 10 divided by 10 is 1, minus 1, 0, 1, 2. Now, what is the formula for calculating the mean according to the step deviation method? The assumed mean plus sum of d dash divided by n into c. So now I have to calculate the sum of this. Again, 1 minus 1 cancel out, 2 minus 2 cancels out. I get 0 over here. Apply the formula. A was 30. Sum of d dash is 0. N is 5 and the common factor is 10. Since here we have 0, this entire unit becomes 0. So what is my mean? 30. So, how do we calculate the mean? By the step deviation method of the ungrouped data. Mean according to the step deviation method is A plus summation d dash upon n multiplied by c. So, these are the three ways of calculating mean in an ungrouped data. We have the direct method, the assumed mean method and the step deviation. Let us look at this question which is given in your book for step deviation method. You are given with the marks of the student. So this is your x. Okay. So this was my x. I assumed my assumed mean to be 60. I calculated d. d is x minus 60. So 40 minus 60 is minus 20. 30 minus 60 is minus 30, 60 minus 60 is 0, 55 minus 60 is minus 5 and so on and so forth. You got all the values of d. Now I need d dash. D dash is nothing but d divided by the common factor. Now what is my common factor that I have? So the common factor that I have over here is, what have I taken to be the common factor? I've taken the common factor to be 4. right? No, 5. I've taken the common factor to be 5. So, 20 divided by 5 is minus 4, 30 divided by 5 is minus 6, 0 divided by 5 is 0, minus 5 divided by minus 5 is minus 1, and so on and so forth. I have my d dash now. Now, according to the formula, I need x into d dash, so I will multiply. 40 divided by d dash is minus 60, 30 divided by minus 6 is minus 80, and so on and so forth. You calculate your sum and you apply it in the formula, which is mean is equals to a plus the sum of x d dash upon n into 2. So, this is how we calculate the mean in your ungrouped series, direct, assumed mean, and the step deviation method. These three methods will get clearer to you when we solve the back exercises based on each one of them. So I'm going to pause here, and in the next part of the lecture, we'll begin with the calculation of mean in the discrete series.